In Texas, they're going hog wild over wild hogs. The feral animals are causing hundreds of millions of dollars of damage to crops across the state.
In the middle of rural Texas, where ranch fences cut across miles of brush and cattle land stretches into near silence at night, a routine wildlife operation was recorded the way thousands of others have been. Infrared cameras fixed to trees, watching for movement in the dark. What those cameras captured, however, didn't match expectations. There's this one Texas Hog Operation footage that reveals something disturbing. Let's get started. The invasion that never stopped. It begins on the Gulf Coast in the early 1500s, when Spanish explorers, moving through what is now Texas and the broader American South, released domestic pigs into the wild as a living food reserve. Totally harmless, no? Well, the idea was brutally practical. Leave them behind, let them breed, return later to harvest meat. Expeditions led by figures like Hernando de Soto carried swine across vast stretches of the southeast between 1539 and 1542. Those animals then slipped into forests, marshes, and river bottoms, and within decades, they were no longer domestic. They were feral, self-sustaining, and spreading without oversight across a continent that had never hosted anything quite like them. For centuries, they remained scattered. Then the second wave arrived in the late 1800s and early 1900s, when wealthy landowners imported Eurasian wild boar into the United States for sport hunting. These were not barnyard animals. They were leaner, more aggressive, and adapted to harsh European terrains. Enclosures failed. Escape was inevitable. Once loose, these boars did not remain separate. They interbred with the already established feral pigs. The hybrids combined size, aggression, and reproductive efficiency. This was a turning point. The population shifted from a nuisance to a long-term ecological threat. By the early 21st century, the numbers had crossed into millions. The United States Department of Agriculture now estimates approximately 6 to 7 million feral hogs across the country. Nowhere carries the weight of that population like Texas. State-level estimates consistently place the number between 2 and 3 million animals, spread across 253 of its 254 counties. Only one county, El Paso, has historically reported minimal or no established population. Over the past few decades, feral hog populations have expanded into at least 35 U.S. states, moving north and west, adapting to colder climates once thought unsuitable. A single female hog, known as a sow, can produce 2 litters per year. Each litter averages between 4 and 12 piglets, depending on environmental conditions. Under ideal circumstances, with ample food and limited predation, a population can double in as little as 4 to 6 months. That growth curve doesn't just challenge control efforts, it overwhelms them. Remove 60 to 70% of a local population in a year, and the remaining animals can still rebuild their numbers within a few breeding cycles. Field studies conducted by Texas A&M University have repeatedly demonstrated that partial culling leads to rapid population rebound, often with animals dispersing into new territories under pressure. The animals themselves are engineered for survival in ways that complicate every attempt to contain them. Adult feral hogs can weigh anywhere from 100 to over 300 pounds, with some large boars exceeding that range. They can run at speeds approaching 30 miles per hour, jump barriers up to a meter high, and navigate dense brush with ease. Their diet is omnivorous and opportunistic. Roots, crops, insects, carrion, and even small vertebrates. This flexibility allows them to thrive in environments ranging from agricultural land to forests to semi-arid regions. Unlike native wildlife, they are not constrained by narrow ecological niches. They adapt quickly and repeatedly, and they remember. Research has shown that feral hogs possess advanced spatial memory and learning ability. When exposed to traps or hunting pressure, they alter their behavior almost immediately. They become nocturnal. They avoid bait sites. They shift travel corridors. Entire groups, called sounders, can learn to bypass a trapping system after a single negative encounter. This creates a cascading problem. Every failed attempt at removal doesn't just miss animals, it educates them. The next attempt becomes harder, the margin for error smaller. Geographically, their spread follows patterns that mirror human infrastructure. River systems, agricultural corridors, and fragmented forests provide ideal pathways. In states like Oklahoma, Georgia, and even parts of the Midwest, populations have surged over the past 2 decades. Climate adaptability has extended their range further north than expected, with confirmed populations surviving winters that were once assumed to be natural barriers. This expansion is opportunistic, driven by food availability, water access, and the absence of large-scale predators. A $3 billion war humans are losing. Flat rows of corn outside Texas, irrigation lines running clean and straight, soil turned and ready. Then morning comes and the field is gone. Obliterated. Entire sections ripped open overnight, roots exposed, ground churned into something closer to a battlefield than agriculture. This is the quiet front line of what the United States Department of Agriculture estimates is a $3 billion annual problem across the United States, with Texas alone absorbing roughly $500 million of that damage every year. The destruction is not random. Feral hogs move in groups of 20, 30, or even 50 animals strong. They don't graze. They root. Their snouts act like plows, tearing into soil in search of roots, insects, and anything edible. In a single night, a sounder can destroy acres of crops that took months to grow. Cornfields, rice paddies, peanut farms, nothing is spared. In 2020, farmers in central Texas reported losses exceeding tens of thousands of dollars from single incursions. It's not just the crops themselves. The soil structure collapses under repeated rooting, increasing erosion and reducing fertility. The land is left vulnerable long after the animals move on. Then comes the collateral damage. Fences don't stop them. They push through or dig under. Irrigation systems are shredded. Water lines are exposed and broken. In some documented cases, hog activity has damaged underground cables and disrupted infrastructure tied to farms and rural properties. Golf courses in suburban areas have been torn apart overnight, their manicured greens reduced to uneven dirt. Airports have reported runway incursions. So the response escalated. Traditional hunting wasn't enough, so large-scale trapping systems were introduced. Modern traps are no longer simple cages. They are engineered systems. Steel enclosures with remote trigger mechanisms, cameras streaming live footage to a rancher's phone. The strategy is precise. Wait until the entire sounder enters, then trigger the gate. Miss half the group, and the operation fails. The survivors learn. They don't come back. This is based on observed behavior repeated across multiple states and documented in studies from Texas A&M University. When traps proved insufficient on their own, the war moved to the air. Helicopter-based aerial gunning operations began scaling up across Texas and neighboring states. A single flight team can cover hundreds of thousands of acres in days, removing large numbers of hogs in a short time. It's efficient in the moment. Dozens, sometimes hundreds of animals eliminated in a single operation. But the math doesn't hold. The populations rebound. New groups move in. Within months, the same land can be repopulated. The cost, however, remains. A coordinated helicopter operation can run into tens of thousands of dollars before a single animal is removed. On the ground, hunters bring in tracking dogs, but it's dangerous work. Adult hogs can weigh over 200 pounds, armed with tusks capable of inflicting serious injury. Yet even this method runs into the same wall. You remove individuals, sometimes entire groups, but the system absorbs the loss. The population is a constantly regenerating network, and at the center of that network is a problem that turns every victory into a delay. Partial removal fails. It doesn't weaken the population in a lasting way. It fragments it. Survivors disperse, spreading into new territories. They reproduce fast. Within months, numbers recover, sometimes exceeding previous levels. Wildlife researchers have described it as a biological reset. Remove a percentage and the system recalibrates, often with increased breeding rates due to reduced competition. What makes this especially difficult is what researchers began to understand more clearly over the past 2 decades. Feral hogs are not just numerous, they are intelligent. Among large mammals in North America, they rank near the top in cognitive ability. Sounders are social units, often led by experienced sows. When one animal learns to avoid a trap or a bait site, that behavior can influence the entire group. Over time, entire populations in heavily hunted areas exhibit heightened wariness. This is where the war changes shape. It stops being a numbers game and becomes a behavioral arms race. Every new tool, be it a smarter trap, coordinated hunt, or an aerial operation, is met with an adjustment. Not instantly, but inevitably. The animals that survive are the ones that adapt best, and they pass that advantage forward, not genetically alone, but behaviorally. But wait, we may be missing something. The overlooked predator. The feral hog dominates the headlines, but something else has always been there, moving in the margins. The coyote is not new to this landscape. It expanded its range dramatically across North America over the past century, adapting to farmland, suburbs, and wilderness alike. And while it has long been labeled a scavenger or nuisance predator, research over the last 2 decades has quietly confirmed a more specific interaction. Coyotes do prey on feral hog piglets. Wildlife biologists working under the United States Department of Agriculture and state agencies have repeatedly documented hog remains in coyote diets. Analysis of scat samples and stomach contents has revealed hair, bone fragments, and tissue consistent with young hogs. In some regional studies, particularly in parts of Texas and the Southeast, hog-related material appears in a measurable percentage of samples. The vulnerability window is narrow but critical. Feral hogs give birth in secluded nesting sites, shallow depressions lined with vegetation, hidden in dense cover. For the first days and weeks of life, piglets are small, immobile, and entirely dependent on the sow. During this period, they are also exposed. The mother must leave periodically to forage, even if only briefly. Those moments create openings. A piglet, weighing just a few pounds, unable to outrun or defend itself, becomes viable prey for a mid-sized predator like a coyote. Field observations have captured this dynamic in fragments. Trail cameras positioned near known nesting areas occasionally record coyotes investigating or passing through. In some cases, they linger. In others, they move on. Laboratory analysis fills in what cameras miss. Necropsies of coyotes, conducted by researchers studying diet composition, have revealed fresh tissue consistent with recently consumed piglets. This distinction matters. Scavenging leaves different signatures than active predation. Fresh, undigested material indicates recent kills, not leftovers from carcasses. In regions where hog populations are dense, this pattern appears more frequently, suggesting that availability increases the likelihood of predation, even if it doesn't transform coyotes into dedicated hog hunters. And that distinction is critical. Coyotes are opportunistic predators. Their diet is among the most flexible of any carnivore in North America. Rodents, rabbits, insects, fruit, carrion, and even human refuse. They adjust based on what is available, not on a fixed hunting strategy. When small mammals are abundant, they dominate the diet. When those populations decline, coyotes shift. Piglets enter the equation not because coyotes specialize in hunting hogs, but because piglets represent a temporary, accessible food source within a broader menu. What they do not do is just as important. Coyotes do not hunt adult feral hogs. The size disparity is too great. An adult hog can weigh 150 to 300 pounds or more, armed with tusks capable of inflicting severe injury or death. Even a small group of coyotes lacks the physical capability to reliably subdue such an animal. Unlike wolves, which hunt large prey cooperatively with coordinated force, coyotes lack both the size and the pack structure for that level of engagement. Encounters with adult hogs typically end in avoidance. In Texas, Oklahoma, Georgia, and parts of the Southeast, both species occupy the same landscapes. Studies conducted in these regions show consistent, if variable, evidence of piglet predation. The frequency changes with environmental conditions, food availability, habitat structure, and seasonal cycles, but the pattern holds. Coyotes exploit vulnerability when it exists. There is also a secondary role: scavenging. Feral hog carcasses, whether from natural causes, hunting, or vehicle collisions, provide a significant food source. Coyotes readily consume carrion, reducing waste and recycling nutrients back into the ecosystem. This behavior often leads to misinterpretation. The presence of coyotes near hog remains can suggest predation when the reality is scavenging. Distinguishing between the two requires careful analysis, which is why diet studies rely on tissue condition and digestive state rather than simple observation. Coyotes exert pressure at a specific point, which is the earliest stage of hog development, but that pressure is limited by biology, behavior, and risk. However, someone looking at the trail cam footage may see things differently. The predation footage and its interpretation. Across Texas, Oklahoma, and parts of the Southeast, wildlife researchers and landowners have deployed thousands of motion-activated trail cameras over the past 2 decades. These devices, often mounted along game trails or near suspected nesting areas, collect vast amounts of data with minimal human interference. Within that data are occasional sequences that show coyotes moving through areas known to host feral hog nests. In rarer cases, cameras have captured direct interactions where a coyote approaches a nest and a piglet disappears from view. These moments are real. They align with dietary studies showing hog remains in coyote systems. But they are also isolated events within a much larger dataset dominated by non-interaction. The controversy begins when interpretation stretches beyond observation. Some widely circulated videos highlight sequences where multiple coyotes appear within the same time frame. But raw data tells a more restrained story. Coyotes often travel in loose family groups, especially during certain seasons. Seeing 2 or 3 individuals in proximity is not unusual. What's less clear and rarely proven is whether their movements are coordinated in a structured, role-based way or simply overlapping paths. Scientific interpretation leans toward the latter. Field studies on coyote behavior consistently describe them as flexible social animals. They can operate alone, in pairs, or in small family units, depending on resource availability and breeding cycles. During pup-rearing season, for example, adults may hunt more actively and remain closer to den sites, increasing the likelihood of multiple individuals appearing in the same area. But this is not the same as coordinated pack hunting seen in species like wolves. Coyotes lack the consistent hierarchical structure and cooperative hunting patterns required to execute complex, synchronized attacks on large or defended prey. That distinction becomes critical when analyzing footage near hog nesting sites. A sow may leave a nest briefly to forage. A coyote already moving through the area may detect scent and investigate. If another coyote appears minutes later, it may be following the same scent trail, not responding to a coordinated signal. The timing can look intentional when compressed into a short clip, but in real time, these events may be separated by minutes or longer. Trail cameras, by design, capture fragments 10 to 30 seconds of motion, without context before or after. What's missing is just as important as what's visible. But it's not just the coyotes. These hogs are fair game for humans as well now. You've seen these footages over and over again. The real shift in strategy. By the late 2000s and early 2010s, agencies working under the United States Department of Agriculture began acknowledging a hard truth in internal reports and field briefings. Isolated efforts were failing. A single ranch could spend thousands on traps or hunts, only to have neighboring populations refill the land within months. The problem wasn't just the animals. It was scale, coordination, and timing. So the strategy changed. Instead of treating feral hogs as a local nuisance, wildlife managers began treating them as a regional system. In Texas, where populations exceed 2 million, this meant shifting from individual landowner responses to coordinated, multi-property operations. Counties began sharing data, movement patterns, population density, and seasonal activity. Removal efforts were synchronized. Instead of pushing hogs from one property to another, teams aimed to remove entire groups across connected landscapes in compressed timeframes. At the center of this shift is technology, specifically smart trapping systems designed to capture entire sounders rather than individual animals. These are not traditional cages. They are large, circular, or corral-style enclosures made of steel panels, often 30 to 50 feet in diameter, equipped with remote trigger gates and motion-activated cameras. A landowner can monitor the trap in real time through a mobile application. The strategy is deliberate. Leave the gate open for days or even weeks, allowing hogs to enter, feed, and become comfortable. Entire groups, sometimes 20, 30, or even 40 animals, begin to treat the trap as a safe space. Then, at the precise moment when the full sounder is inside, the gate is triggered. One event, one capture. No survivors left to learn and avoid the structure. Studies from Texas A&M University have shown that partial trapping, capturing only a portion of a group, can make the problem worse. The remaining animals become trap-shy. They avoid similar structures, change movement patterns, and pass that behavior along within the group. In contrast, full sounder removal eliminates not just individuals, but the learned behavior tied to that location. It resets the local dynamic, at least temporarily. But even this approach has limits. Remove one sounder, and another can move in. That's why coordination across properties has become essential. In regions like South Texas, groups of landowners now pool resources to deploy multiple traps across contiguous land. Data is shared. Triggers are timed. Helicopter teams, when used, operate in tandem with ground efforts to prevent displacement into untreated areas. The objective is to reduce the window for escape and recolonization. The deeper researchers looked, the clearer the reality became. There was no hidden silver bullet waiting in the brush. Not coyotes, not toxicants, not helicopters, not traps. Every method slows the invasion, but none have stopped the engine driving it. An animal that reproduces faster than humans can remove it, adapts faster than strategies evolve, and turns every temporary victory into another countdown toward the next population surge. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.